Hi everybody, today we're looking at multiple regression with Minitab. In this example, I'm looking at the regression model with home values. Suppose in a regression analysis, we want to predict home prices in thousands of dollars. We're going to use the number of rooms and the distance in kilometers from the city's core. Here's the data that was collected. The first question says, what percent of the variation in the dependent variable is not explained by the independent variables in this model? We're going to round to two decimal places. We have two independent variables, the number of rooms and the distance from the city's core. Those two are working together to help model the home price. Before we go to Minitab, let me show you this in its original form in the homework. What I want to show you is how to easily copy and paste from the homework into Minitab. What I'm going to do is highlight all of the numbers. Notice I didn't take the names of the columns, only the numbers from the columns. I'm going to right-click, copy. Then in Minitab, I'm going to the first cell, right-click, and I want to click Paste. All my numbers came out really nicely. Now, above each column, I'm going to say what it stands for. I know from doing this problem before, it's not going to easily copy and paste from the homework over to Minitab. So my first column is number, and I'm going to do an underline to say rooms. The second one is distance, and my last one is going to be my price. And I'll remember that it's in thousands. I'm not going to put it in Minitab. Next, to get the model, I'm going to go Stat, Regression, Regression again, Fit Regression Model. It's going to ask what the response is. So the response is my price. That's my dependent variable. Then the continuous predictors are both the distance and the number of rooms. This gives me my regression model. Price is $6.94 minus 7.01 times the distance plus 56.9 times the number of rooms. You'll see those same values, $6.94, negative 701, 56.9, and the first column that says coefficients. If you need more decimal places, this is where you can change it. You go to the box with coefficients, click the drop-down arrow, go to Table Options. Here you could increase the number of decimal places. Let's change ours to 4. Our first question asks about the coefficient of determination. So I'm going to scroll down and look for r squared. Here I see it's 78.64%. Since r squared is 78.64%, that tells us the percent of variation in the dependent variable that is explained by the independent variables. To find the percent of variation in the dependent variable that is not explained by the independent variable, we need to subtract from 100. 100% minus 78.64% gives us 21.36%. The regression equation for the output predicts the price of a 5-room house to be $642,009. How far is the house from the city's core? Round your answer to a whole number. Our model says the price is $694.15 minus 7.01 times the distance plus 56.88 times the number of rooms. Because the model is done in thousands, our first step is to convert the price. We want to take $642,009, divide by 1,000 to get 642.009. Next, we'll substitute our values. We'll have 642.009 is 694.15 minus 7.01 times the distance plus 56.88 times our 5 rooms. We can multiply 56.88 times 5 to get 284.4. Then we'll combine the 284.4 with 694.15 to get 978.55. We'll move that number to the left, which gives us 642.009 minus 978.55, which is negative 336.541. Because that's equal to negative 7.01 times the distance, we'll divide both sides by negative 7.01 to get that the distance is 48 kilometers. To finish up the problem, we're going to use the regression coefficients from the output to estimate the price of a 4-room house that is 45 kilometers from the city's core. We start by bringing back our model, then we substitute in the distance of 45 and the number of rooms, which was 4. When we throw that in the calculator, we get a price of $606.22. But again, this is in thousands. When we multiply by 1,000, we get a price of $606,220.